Students, welcome to electrical power system lectures. Previously, we have discussed about short transmission lines, what are the ABCD parameters, about medium transmission lines, different types of medium transmission lines. There are basically three models to calculate the capacitance effect of medium transmission line. The first is end condenser method. Second is T model or T circuit, and third one is pi circuit. So today we discussed about how the capacitance calculations and ABCD parameter calculations possible in a T model or T method. I am Manan Desai from Department of Electrical Engineering, Dr. Subhash Technical Campus, Junagadh. The learning outcome for the students are, after discussing this lecture, the students able to understand the methods of different methods and its calculations, vector diagram, and ABCD parameter of medium transmission line T model. So students, this is a medium transmission line where C is connected in the middle of line, and there are multiple or we can say capacitance effect are affected thoroughly to the transmission line, so we cannot neglect it, and so we have to calculate as a lumped parameter. Now nominal T method. So what is nominal T method? Here it is like T. The circuit is shown as a letter T, so the name is T circuit. The capacitance is assumed to be concentrated at the middle point, and capacitance is assumed to be concentrated at the middle point of the line, and the half line resistance and reactance. So students, here in the figure, this is a half resistance and half reactance. Half resistance and half reactance. So when the capacitor is concentrated at the middle of the line, the total resistance and reactance are considered as a half part as a sending end side and half part is a receiving end side. Thus, in this arrangement, at the terminals of the condenser, the voltage has value V, intermediate between the sending end voltage Vs and the receiving voltage Vr. Now, a capacitor current IC is leading. Obviously, it is leading because it is a capacitor, and capacitive current is leading by its voltage. So IC is leading V by 90 and accordingly flows over first half of the line from the sending end. The current in the receiving end IR and in the sending end and half of the line IS, which is in the phasor sum of receiving end, the current IR and charging or capacitive current IC. Taking receiving end phase voltage as the reference phasor, we have calculations. VR is equal to VR1 plus J0. This is a VR. And receiving end or load current, we can say IR is equal to two parts. We have two parts, cos phi R minus J phi R. So voltage across the condenser is V. So here voltage across the condenser V is equal to VR plus IR is the half, IR Z by 2 is equal to VR plus IRZ by 2 R plus JX. See this R plus JX. VR is equal to 1 plus J0 plus 1 upon 2 IR cos phi r minus J sin phi r, and Z is equal to R plus JX. Now capacitive current. What is capacitive current? So we can say J omega CV. J omega CV. So omega means 2 pi f. So IC is equal to J 2 pi f CV. Now IS. So IS is IR plus IC. IR plus IC means here the IS here IS is IR plus IC means receiving end current plus capacitive current. The both summations of currents is IS. Now IR, so we have IR cos phi r minus J sin r. So we can put here plus IC. We have IC value also J2 pi f CV. Okay, so we got IS sending end current. Now calculate about sending end voltage Vs. So Vs means total voltage across condenser V, and V means VR plus IRZ by 2. Ultimately we have V is equal to VR plus IR by 2 R plus JX. So we can put here. Okay, and transmission efficiency is output upon input. Output is VRIR cos phi. Input is output plus losses. So output is VRIR cos phi r, and these are the losses, IR losses. Now vector diagram. So from the beginning and the reference phasor OA. So what is OA? OA is a voltage to neutral at the receiving end. It is a VR. Then OB. OB means IR, receiving end current. OB means IR drawn by, it is lagging by phi r angle. Phi angle degrees with behind the OA. Obviously it is lagging because inductive effect or actually the transmission line, whole transmission line is inductive. So phi r is the load power factor angle. Now AC is drawn parallel to OB is the ohmic voltage drop in the receiving end half line. CD is drawn 90 ahead and of OB is the reactive voltage drop in the receiving end half of the line. So this is a IR losses, this is a reactive losses, again this is a IR losses, and this is a reactive losses. So we have the resultant vectors. So OD is a resultant vector of first half, and OH is the final resultant vector of both half. So OD is a voltage across capacitor BF drawn 90 ahead of OD. So this is a V, and DG drawn parallel to OF is the ohmic voltage drop in the sending end half of the line. GH drawn 90 ahead of OF is the reactive voltage drop. So finally OH is a sending end voltage, and phi S means it is the angle, sending end voltage angle, which is lagging with IS. So this is a sending end current. It is a resultant of receiving end current and charging current or capacitive current. So it is resultant, and the voltage resultant is Vs, means sending end voltage. So students, you see here phasor diagram. So in ABCD parameter of T model, we have two loops. So we can apply KVL here in these two loops and KCL here in this junction. So sending end voltage and current can be obtained by application of KVL KCL. Now voltage between the node A and B, VAB. So VAB is equal to VR, this VR plus this is Z by 2 into IR. Current in the capacitor can be given as this is IAB. IAB is voltage between A and B, VAB, and the total ZAB impedance. So we can say it is admittance into voltage. So IAB is equal to YAB. Now by Kirchhoff current law at node A, on this node we apply KCL, and what we gain, it is IS, sending end current. So IS is equal to IR plus IAB. This is IR plus IAB. This IAB. IS is equal to IR, and what IAB is? IAB is YVB. So we can put here IS is equal to IR plus Y into VAB. IS is equal to IR plus Y, and further the VAB is VR plus Z by 2 IR. Okay, so ABCD parameter of. So by using Kirchhoff voltage law, Vs is equal to VAB plus Z by 2 IS, and we have derived VAB value here. VAB is equal to VR plus Z by 2 IR. So this will be put here, V by 2 Z by 2 IR plus Z by 2, this is Z by 2, and IS value. IS value is IR plus YVR plus YZ by 2 IR. See here, YVR plus 1 plus ZY by 2 IR. This is IS value. Now equation of sending end voltage Vs, current Is can be written as in matrix form. Vs upon Is is equal to, first we take VR term. So we have VR term, see here, this is a VR and VR. So combine to both, we derived 1 plus ZY by 2, and then IR term. This IR term and this IR term will be merged, and we derived Z1 plus ZY by this Z by 2, and this ZY by 2 is multiplied, so ZY by 4. So this is a second IR value. Now from the IS point of view, IS is equal to, here we put the term in VR value. So we have this BR value is Y, only Y, and IR value is in 1 plus ZY by 2 in IR form. So this ZY by 2 IR. So ultimately in this form we derived ABCD constant of nominal T circuit method is A is equal to D. See this both are same. A is equal to D is equal to 1 plus ZY by 2, B is equal to Z1 plus ZY by 4, and C is equal to Y. So I hope you understand ABCD parameters of T model. Thank you.